Hello, and welcome back. Oh, don't need today. Welcome back to the Fermi on YouTube. My name is David Flanagan, although you may know me across the internet as Raw Code, and I have been using the Fermi on YouTube channel and these sessions to guide you through the advent of spin. This is our third session, so if you're new to this or you have no idea what I'm talking about, go back and check out episodes 1 and 2 where we complete challenge 1 and 2 of the advent of spin. Now, the advent of spin is a series of small, almost trivial exercises to get you familiar and comfortable with writing or compiling code to be WebAssembly modules. Spin applications allow us to use our favorite programming languages provided they have a WebAssembly target. You've seen me use Grain, Rust, TypeScript, and I think that might be it so far. However, many languages now have toolchains for compiling to WebAssembly. And the great thing about spin applications is you write in your favorite language or a language that you want to experiment with, compile it down and deploy it to Fermi on Cloud. This process has been a whole lot of fun so far, and I'm looking forward to taking on challenge 3. So if you have any questions at any point, please feel free to drop them into the comment section. And also, we have a very active Discord with other people also working through these challenges. The link will be in the description shortly after today's episode. So come and say hello, and we look forward to seeing what you build with Spin and Fermi on Cloud. All right, let me share my screen, and we're going to work through challenge number 3. So challenge 3 is the first time we're going to be taking a look at Bartholomew, and Bartholomew is a static site generator that allows us to actually serve HTML, JavaScript, and CSS via a WebAssembly module and deploy it to Fermi on Cloud. So our mission today is nice and simple. It's actually probably the easiest one yet. All we need to do is clone the Bartholomew site template, which I'll show you where that is in just a moment, and deliver an H1 with welcome to the advent of spin in it, and Santa's on his way in the body. That's it. The point of this exercise is to, one, get you aware of Bartholomew so that you can see that you can build static hey Anish, thank you for joining us. So that you can build static websites and deploy them on the Fermi platform, and those can consume WebAssembly modules. However, something we'll take a look at in the coming episodes is that you can actually deploy any front-end framework and serve those assets over the Spin file server component. So there's a whole lot of really cool stuff that you can do by using Spin as a framework for these applications. So today we're just going to focus on Bartholomew, see how to get started and get it deployed. So I'll just pop your comment up. Thank you for your kind words. I've lost my mouse. There it is. Awesome, thank you. I'm glad you find these sessions helpful. I've really enjoyed them. It's been a good opportunity for me to kind of play with Spin more and experiment. You know, in the last episode, I got to play with the freshly baked TypeScript SDK that was announced only a matter of hours before. So it's a lot of good fun for me too, and I really enjoy it. Okay, so I have the site template here. So you will find the Bartholomew site template at github.com/fermion/bartholomew-site-template. And you can just clone this straight up. This is a public repository, so nice and easy. And I'll just do make dir challenge 3. Oops. And I will clone into this directory. Now we see that we have a default content structure or directory structure here. We've got templates, static scripts, modules, content, and config. We'll take a look at a couple of these as we explore and work through this challenge. We actually don't need to do a lot in this challenge with regards to changing the way that Bartholomew works or tweaking the theme. We're really just going to focus on how to take content and push it to the web. Let's pop this open. And you'll see in the content directory, all of the content that we are working with is just Markdown. So you'll see here that this is the front matter. We need some sort of title on it. So you can set this to whatever you want for this page. There's a description, which is going to help for SEO optimizations. You can specify different templates, and those can be provided inside of the templates folder. This uses the handlebars syntax, which I'm sure is going to be familiar to most of you. Very similar to Jinja, exactly. Jinja from the Python ecosystem. In fact, I think this is now just a ubiquitous template and syntax across all major languages and frameworks. Where were we? Index. We can specify the date that this was published, and then we end the front matter. So if you're not familiar with static site generators, it's very common for them to use 3 dashes at the start and accept any YAML. So we'll just say, yeah, homepage, like so. And then everything after that is Markdown syntax. And this is what you would expect or find on, you know, GitHub and anywhere else that supports Markdown syntax. Some CMSs even support it now. So we can take a look at the blog, and we'll see this one is just got a little bit of less comments. You know, you don't really need all of that twice. And then this here, I'm actually just going to delete the blog. We don't need it. So, like all spin applications, we can do spin up, follow, all. Oh. I have something running on port 3000. Do I? I didn't think I did. Alas, I actually have no idea what that could be. There's not anything defined here. You know what? I've never even modified the listening address for a spin application before. So off the top of my head, I don't even know how to change it. I'm assuming we can specify a listen parameter here. Yeah. Yeah. Who knows? So let's do the follow all listen 0003001. Now, this is one of my favorite things about Bartholomew. If you've used previous static site generators, there's always a build step. And we don't need to worry about that. It all happens as part of the WebAssembly module for us. So we haven't done a spin build here, but we can go to our web browser and go to 3001. Oh, and I have a TOML error. So let's fix that. How did I get a TOML error already? I wrote YAML. Cool. Whew. Yeah, I said YAML at the start, but I'm completely wrong. It's TOML. So this is Spin as a framework. It's written in Rust. The Rust ecosystem seems to prefer TOML and the Go ecosystem too over YAML files, and the front matter is all formatted as TOML. So don't make that mistake. Now let's go back to our specification. So if we go to the challenge, then we need to return a 200 on slash. This is already happening because we have an index.md. If we remove the index.md, this will now return a 404. So I think we'll keep it there. we have to make sure that the content type HTTP header is text dash or slash HTML. Easiest way to confirm this is just to use curl. So we can do curl -v localhost 3001, and we pop up, and we'll see that we do have a content type that contains text /HTML. So that should pass our test, and we should be good to go. We must have an H1 that says advent of spin. So let's pop over here, say H1, and then we'll just copy the text so we don't mess it up. Like so. And the last is the page must contain the text Santa's on his way. We'll just wrap this. Oh, we don't need the P tag. In fact, we don't even need the H1 because this is Markdown. So we can do so. And that is us. So now we can run the test.hurl. So let's grab this. And then copy this here, test.hurl. And like all of the hurl tests that we've ran so far, we can do hurl --test, test.hurl. Oh, the port is wrong. There we go. Cool. So something failed. Let's scroll up. It says that our body does not contain Santa's on the way. Has it been HTML escaped? Where's the content? Oh, it's not there. Yeah. Because we changed the content, so we spin it back up again. Oh no. Alright, let's debug. So my body contains Santa's on his way. Well, let's check the web page. Santa's on his way. Yeah, it looks good. Santa's on his way. Why is that assertion failing? Let's remove it for a moment. That passes. That fails. That is peculiar. Let's be very explicit. It's weird that it's kind of wrapping it in this extra bracket. Nobody's reported an error on the repository, but I'm going to remove it because I don't know why that's failing. So now this passes. So this is, like I said, it's a really... Oh, Dennis, thank you in the chat. So I'll pop that up just now, but... Oh, I can't find my mouse. There we go. Anish was in there too. Thank you both. So we just need to escape this, apparently. The escape is not valid. I'm removing it, and I'll update this. Alright, I've angered at everybody. Oh no, I didn't rebuild, did I? Right, okay. Yeah, interested on escaping there. That's interesting. So, hurl is not a tool I have used extensively, but I thought it was quite interesting for providing simple assertions against HTML and JSON. And in fact, it's been fantastic so far for the last couple of challenges. So, just interesting how it handles the escaping and stuff there. But we're not going to worry about that. So that's it. We have created a static website, Web Bartholomew. satisfied all of the specifications, we can now submit this with the HURL request, dropping in our service URL, and that will get you into the special database as we start to give away swag towards the end of the month. So remember to always submit your service URL. Now, there's just one more thing I want to talk about. This is a fresh Bartholomew install, and you may be wondering how do you add or integrate this with the components that you've written previously. So this is just something that I found that works well, and that is if I do services make spin new, and let's just do a grain one. Should be nice and simple. We'll call this hello world, and then go back up a directory. This is what I found works particularly well, is to have Bartholomew or any static site generator or JS framework that can be bundled into raw HTML, CSS, and JavaScript at the top level, because this is kind of the entry point to everything that you're going to do. So, the services being a subset or a directory within here. And then if you just go to your TOML here, rip out this bit and delete it. And then add your TOML here and then update the paths. So this would be services, hello world, main.wasm. We want this to respond on the root hello world. And see if I can remember how to set the work there. That was a whole 2 days ago, so it was a long time. Like so. So in theory, we now need to do a spin build, because the grain application actually won't have been built yet. Hold on while I approve the grain compiler. That must have been updated by Brew at some point in the last couple of days. Yes, run. Now the grain compiler is a little bit slow. In fact, I probably should have used Rust. But we'll let this compile, and then we'll run the spin up, and you'll see that we have the two applications or the two components within a single spin application. So I like Bartholomew or your static site generator being at the top, and then using a directory structure to provide all the services in between. So just because I know that Dennis and Anish in the chat have already worked through this challenge, I'm curious. Did you do it the same way? Did you integrate it with your other services? This will become more important as we get on to the create your own adventure challenges towards the end of the month. So I'm just curious. Let's run spin up. Oh, and then look at the port problem. So let's do this. And now we can do curl hello world. Perfect. Yeah. So I find this works well. As you can see, we have Bartholomew. We got the static wildcard path, and then we have our hello world. So we've got multiple services working together alongside Bartholomew, delivering static assets and API functionality, which I think is pretty neat. So that's us. We will be back on Friday as we work through Challenge 4. If you haven't seen Challenge 4 yet, this one it's fun and interesting. We're kind of kicking it up a notch, and we want you to be able to build a function to calculate the distance between two lat-long coordinates. So you'll see this one will either require you to be extremely mathematical and go do lots of hard work, or, and this is what I want everyone to do, you'll notice here, is that we want you to find existing packages within the ecosystem that you already use. In Rust, there's packages to do distance between lat-long. There's packages to do calculations or conversions from miles to nautical miles, etc. The same in TypeScript, the same in .NET, the same in whatever language you want to use. So don't overthink it, have some fun, and we'll see you all on Friday. Have a great day. I'll speak to you all soon.